So question 2 of M1 IAL June 16 Edexcel is a collisions question. We've got them moving in opposite directions, always something to look for. We've got masses of M and Km for P and Q, and we're given the speeds. They're going, P is going with speed U. It's got mass M, it's going with speed U, and Q is going with speed 2u in the opposite direction. Then the mass of that is Km. And then I think we're told somewhere that the direction of each is reversed. So we can call this one, and we're given the speeds of them as well. Each of them is halved, so if this one was u, then half of that is u over 2. And if this one was 2u, the half of that is u. And then the mass there is m and km for particle p and q. Okay, so we can use conservation of linear momentum. Making sure we're careful with signs, calling this way positive. We got m times u, mass times velocity. Take away, because it's going in the opposite direction, 2u times km. This is also going in the opposite direction, so let's take away m times u over 2. And then plus, going in that direction, kmu. Now m and u cancels here. So we're left with 1. Take away 2k equals 2. We've still got 2 on the bottom, so it's minus half, plus k. So that gives me 3k equals to 1.5, equals to 3 over 2, 1.5. So k equals half. Okay, that's part A. Part B, we have find the magnitude of the impulse on Q exerted on Q by P. Well, during the impulse stage, we'll have an equal and opposite impulse acting on these two here. One of, if we call this way positive, then the input, that's the way the impulses are going to go for P and Q. So I'll do it on Q, but it might be worth doing it on P just to check the answer as well. Normally, if I have time, I'll do it on both because it's easy to make a mistake with signs on these questions. So let's do it on Q. So on Q, we're going to use the impulse as change in momentum. So we've got impulse equals to the mass, and we are given the mass as just m, because it wants it in terms of m, of its km, so it's half m. Okay, and then that's half m times v, final velocity. Remember, everything this way is positive, so the final velocity on this one is equal to u, and then the initial velocity is equal to 2u, but it's going in the opposite direction. So that gives me impulse is equal to 3 over 2 mu. So I'm going to do, that's the answer, but I'm going to do it on P just to check. It's kind of thing to do after you kind of finish the paper. Check if you've got enough time. Check by doing on the other particle. So if I go on P, we've got impulse equals to, now again taking everything as positive, we in this direction, the mass is now still just m. Now initially this had a velocity of u, but it started off finally with velocity u over 2, so it's minus u over, sorry, it finishes off with a velocity of u over 2. The final velocity is u over 2. And the initial velocity is u, but the u over 2 is going in the opposite direction, so hence minus u over 2. Take away, because that's what's in the formula, u. So that gives me minus 3 over 2 mu, and it's negative because it's going in the opposite direction. Incidentally, if you did do that, you would lose a mark if you didn't then go on to say the magnitude of the impulse is equal to 3 over 2 mu. That must end up with a positive because it talks about magnitude. Okay, so that's question 2.